Hello everyone, welcome to my channel. So today I have a new video, and that video will be looking at spectrum analysis using the RRL plugin, which is based in the RRL database, which is an Australian spectrum database. So I'm going to demonstrate how you could use the plugin to do some channel reuse analysis, like utilization, spectrum utilization. We're going to do some spectrum scanning, display signal level predictions, using it's all based on predictions, and conduct some availability analysis and so on. So let's get started. First, we're going to run the plugin. So this is the plugin, RL plugin. So basically, the plugin is that it's an interface just designed to run queries, and these queries are based on land mobile radio or point-to-point. There's a frequency range and there's a geographical boundary. So basically, it's a multi-dimensional queries, and these queries you can specify the type of the device, the object, the transmission object. It could be reception only, it can be transmission only, or both. So you can run filters and queries based on frequency range, channel plans, band plans, and so on. And it could be done also based on geography, and we've got different options there. So let's get started. So basically, I want to see here in that state, in New South Wales, I want to see I want to run some stats, some analysis for spectrum usage for example, the GSMR, the rail network, which is based on GSM. So I want to be able to display the signal levels or spectrum usage and so on. So I'm going to use land mobile radio because, like I said, I'm not doing microwave links here. I'm not doing studio links. I'm just doing an LMS service or LMR service, or a basic transceiver equipment. So I'm gonna go and specify only transmissions, because I'm really only interested in emissions, not in channels designated for reception. So I'm only interested in transmission parts of the spectrum. So that's pretty much it here for the mode. You go to frequency range and you choose from here the band of interest. So the band that I'm looking at is the 1800, should be called DCS, maybe DCS 1800. So you look for DCS, and here you go, that's the one. So DCS 1800 band, and we know it is FDD. It's FDD band, not TDD band. So I'm going to focus on the higher part of the spectrum. So you can see here we've got all the reception frequencies and transmission frequencies. So no need to run a query for the entire thingy. So I'm going to start from the lowest transmission frequency. Here you go, starting 1865, all the way to the highest transmission frequency. So I really limited the query going to the server to transmission part of the band. And now we go to the boundary, and the boundary we choose map extent. So map extent means the canvas here, or the frame. The frame will be your bounding box for your geographical query. So yeah, I've got most of the state here in place. I mean, we also see we are going to Canberra, in fact, but that's okay. We can filter later on by a licensee if you're looking specifically for the licensee who's operating that spectrum. So that's it for me for now. I'm gonna go run that query. So what the query does is it will sorry, it looks like it was taking different boundary, so I'm gonna deactivate it for now. Zoom out a bit. Wollongong, Newcastle, Canberra. So I'm gonna run the query again using the map extent. Run the query. Yeah, that's the number I'm looking at. So it was previously framed to different canvas. So here we go. So this is the entire boundary that I selected. So what I'm going to do next is I'm going to filter by the licensee. But you can see very clearly here that this is the rail network, and you've got some a reuse of that band somewhere else here and there. So there could be some sharing, um, some sharing of that spectrum somewhere else, or it could be partial overlap or something like that. That's fine. So what I'm gonna do here now, I'm gonna go to the filter here. I'm gonna filter by licensee. So you can see you've got multiple licensees sharing the spectrum um, that I used in the query. So you've got Connected Farms, you've got Pivotal, you've got Sydney Trains, Telstra, TPG, Vodafone. So this could be partially overlapping, like I said. So I'm going to limit or filter by Sydney Train. So around Sydney Train now, the number of devices or transmitters reduced from 3,489 to 2,993. So I can uncheck the existing KML and then draw the new one. So if you go click plus here, it will draw the filtered station. So you go draw here, and we should be able to see the part of the network which is owned by City Train. So you see here, you go filter again by licensee. Now you only see City Trains because he filtered out the rest. So that's the Sydney Train spectrum effectively, and that's the devices that classified as transmission in the GSMR band, the DCS 1800 that I specified. So next is I want to see what would be the signal level received at specific location and what would the spectrum look like for that. Okay, I can do a lot more like availability and so on. I'll be showing different ways to do the analysis. But let's make it simple for now. So we've got here the analysis spectrum usage. So if you run the spectrum usage analysis, maximize it. So you can see there's only one licensee, which is I agree because I already deleted the rest. Okay, I could have kept them then to have a full view of the spectrum instead of filtering them. And you can see Train only registered 200 kilohertz transmissions. So I'm gonna go and filter the 200 kilohertz only, and then the license type is a spectrum. Sometimes it's coming as an apparatus, or it could be a spectrum license or something else. So depending on the advertised type of spectrum captured in the ACMA's RRL database or extracts. So you can just go select all if you want, and then you can plot. You can plot this. Now before I plot it here, I can specify a receiver location to do the relevant analysis. So I can put the somewhere here in Surrey Hills or even in Central. You can go closer to this is Sydney Park, Australian Golf, blah blah blah. So I could choose somewhere here. This is the train station here. So that's your reference point for producing the graphs, and that reference could be used for distance computations or signal level computations. So I'll do both of them. And you see here there's a channel plan, so you can overlay the channel plan that you selected in the previous step here in the frequency. So you can actually use this as a backdrop for the visualizations. So let's go and do it, frequency plan, and then let's go select RSSI, signal level based. So this is the signal level analysis. Really basic predictions here. The idea is just to give you some sort of indication of the relevant strengths of the signal in compared to other channels. So basically, I implemented here the extended Hata Okumura Hata model embedded into the tool, and you can choose the environment, urban or suburban or open. So you could go, for example, something like suburban, and then it will give you more optimistic signal level. And this is the minimum or the max that you want to display, and then the receiver height that you'll use for the analysis. So imagine you're standing at the spot here with the receiver 1.5 meter height, and with the device supporting signal range from neg 120 to neg 40, and with normalized antenna gain. So what will be the signal level seen here? Okay, and we're going to really filter it by Sydney Train and the spectrum that they have in their range that we ran the query over. So go plot, and then you see very clearly now you've got uplink band and downlink band. And the uplink band here obviously is empty because we remember the query that we ran, it was really limited to transmission types transmission type ports or devices. So that's why these are not showing, because these are of the type R. These are of the type T. So another reason is because they've got no power level over there, so it would be zero power level. Whereas here we have 83 watt ERP or 8.3 or something like that. So you can just zoom in like this by holding down the left button, the left mouse click, and then just scroll. So the vertical axis is obviously here the signal level RSSI, and the horizontal axis is the frequency, the frequency domain. So if you see a label, you see that label here, that means you've got a frequency. If you see no label, that means you have no frequency. So I can clearly say that these 1, 2, 3, 4, 5, 6 are really not used. Okay, this part is not used, and also this part here is not used. And also I can see that this frequency here is not compliant in terms of the bandwidth and the center frequency. So ideally you want to see the channel right in the middle of or the transmission frequency right in the middle of the designated channel number. The ACN should be in the middle. You see, all of these are okay except this one. It's drifting a little bit. I'm not sure why. I'm not sure. It could be an old record that hasn't been deleted, hasn't been well registered or something like that. But yeah, this is raising flag here. And you see there's a bit of a gap here. And the same here, there's a bit of a gap. And that gap maybe is working as a guard band because there's a broadband here. Normally would be Vodafone here, broadband LTE. So you can see, guys, when you hover the mouse here, you can see the signal level and the center of frequency as well. Depending where you position your cursor. So you can see next 75 roughly dBm at this stage here, and this one has a weak signal here. You can see that's a weak signal. So you're looking at neg 117 dBm, and you see here this is empty because obviously there's no label. So this is really a nice way to understand what would the spectrum look like if you have a scanner there, or if you want to really identify reusable frequencies. So I can clearly see the signal is very weak. So maybe I could reuse this, and this one is not used, then maybe it could be used, and so on. So this is really a nice way to present the spectrum. And I could have done this based on distance as well, so how far it is. And distance is also very useful because if it is reused over, let's say 200 kilometers, then maybe it's reusable because it's too far away. And here the bottom graph here is really the number of devices distribution from the reference point, which is here. So you see most of the base stations are deployed within 50 kilometers. So the first 50 kilometers from the central here, the first 50 kilometers, you've got plenty of devices found, or GSMR towers in that case. There's lots of them in the first 50 kilometers. After that, it's really become a little bit quiet, and then picking up again at 99 kilometers. So this is just the distribution of the number of devices versus distance. So if I go and use the distance as a criteria and I plot, so you can see now here is giving you an indication how far is this frequency been utilized from my reference point here, the central. So it's telling me how far. So you see this part of the spectrum, the lower part of the spectrum, has been used really under 20 kilometers. Under 20 kilometers has been already used. That part of the spectrum is used further down. So this is probably urban, using the urban here in the city, near the city, and here used outskirt or further further away from the central, like suburban areas and rural areas. They use that part of the spectrum. So this is giving you a different perspective. And this frequency, for example, here, it was 120 kilometers away. So if you are in that spot and you want to reuse a spectrum, then this is a good candidate because this frequency is really used about 124 kilometers away. So this is the distance approach, and then this is the RSSI approach. And RSSI approach, like I said, you can change the environment to urban, for example, and then urban we expect it to give you a lower. We expect it to give you a lower signal level compared to suburban or open. So this is the suburban. The other one was the urban. So this is how you can conduct this kind of analysis on actual database, live database, and then extract all this spectrum knowledge, and then help you find a vacant or reusable frequency if in case you're doing special events, trying to find a frequency for camera or professional microphone, or even professional walkie-talkies and stuff like that. So DMR and so on. So this is really a good approach to understand spectrum utilization from the database perspective. Now, lots of these can be exported if, in case you want to feed these channel plans to a measurement device for field measurements. So let me close this one now. Now I want to show you another perspective or a different technique to understand spectrum utilization. So normally I used something like a proposed point or a test point on the map. So let me find the central. This is central. So this is a basic CSV file that has a specific location. It's just a central station, effectively, latitude and longitude. So this is only one location. You can add other locations, Redfin or whatever. It could be a stadium, it could be wherever, okay, or a mine site. So the idea is to study the spectrum at this location or multiple locations. Why multiple locations is useful? Why did I implement this as a CSV? Because sometimes you want to design a network, not just one site. You want to do a network, and when you do a network, then you need to test multiple locations, especially at the edge of the network. So I'm going to use this as a use case, and I'm going to run it. Go to the tools, and then you see this PTS spectrum finder. So this is originally designed to meet the requirements of PTS licenses under ACMA. So we call it PTS spectrum finder. So PTS spectrum finder is pretty much fully automated. All you have to do is just select the band of interest, DCS GSMR. I'm going to use the same example. And I'm going to limit it as before to TX only. I don't want to confuse myself. And I'm going to search up to 200 kilometers. And I'm going to use that example here, central. So click circles here to display a circle. So this is the geography for the geographical boundary for the query. So we're going to run a query in that frequency range up to 200 kilometers from that central point, and I'm going to study the spectrum utilization in that area. Okay, that's the idea. So you go and run a query, and it will automatically extract the registered devices in the database in the area. And like I said, you could do it over a list of sites. Then you do the analysis. So this is the RX part, and this is the TX part. So I'm just going to go and zoom in here. So the horizontal axis is the or the x-axis here is the central frequency of the raster of the channel plan. That's a channel plan. See, this is the plan ACN1, ACN2, ACN3, 4, 5. So here no more we are displaying the device's frequencies as is. Actually, we are studying here the raster itself, and the idea is to identify what ACN, what absolute channel number is used or not used, or how often it was used. So horizontal axis is the central frequency of the rasters or the ACNs, and the vertical axis is the number of devices encountered in the database overlapping partially or completely with that raster. Okay, partially or completely. So number of devices, normally you need to no, you don't need to divide by 2. I was thinking maybe you need to divide them by 2, but in fact no, because we only have the TX here. So here what I understand is that channel number 1, 2, 3, 4, 5 are not used at all. Okay, they're not used. And I can also understand that 8, 9, 10, 11, 12, maybe 13 as well. Yeah, 13 are not used. Are not used. And I can see the lower part of the spectrum, which is 14 to 26, are underused. So they used less than maybe 5 times or 10 times. That's the reuse in the whole network. Because you can reuse the frequency for the case of GSMR. So it has been really underutilized, maybe for a very good reason, because these are maybe used for the pilots or specific network, something like that. But you can see from 27 up to 61, they have been used more than 80 times, more than 80 times. So because each tower would have maybe 4 to 8 channels, depending on traffic demands. So you can see they have been really well utilized. They have been well utilized. So this is how often a channel is used. So it gives you a perspective into the efficiency of the frequency allocation. And that part here is a constant for a good reason, because this is partially overlapping, in fact, with Vodafone. So there's Vodafone probably here. Vodafone has broadband. So broadband is overlapping here with these channels. But these channels are not used by the GSMR, obviously. So, and it could be overlapping somewhere a little bit outside the major cities. Yeah, but this is here not important for now. So this is the utilization. So yeah, this is, guys, how you can conduct that spectrum analysis on actual database. Now I can also do things from measurement perspective. There's a new tool I was working on that allow me to interface with a monitoring device to conduct a bit of analysis. So let me just run this. Just to show you, just to make this video a bit more complete, I'm going to show you how you can monitor a band or channel plan in order to understand the spectrum usage using real-time measurements. I might just open it here. It's open anyway. So let's have a look. So this is a tool, the interface, a software that interface with actual measurement hardware. So you can see the hardware here is BB60C, and you can see the details of the hardware, like serial number, the device name, and so on. So this device is connected physically to the computer right now, and I can connect the device and I can do spectrum sweeping. And also I've got here measurements done in the past. These measurements, I can actually display them here. I can analyze these measurements. This measurements here, for example, was done. You can see where the file is. You can see the number of sweeps. You can see the frequency range. You can see the header here. You can extend the header. So in the header, I can see the first bin, center frequency, and I can see the center frequency of the sweeping, the RBW, reference level, and so on. So this is playback. Okay, these are measurements that I saved on the computer. So I can just go here and then playback. And in the playback here, you can see the location of the GPS, and you can see also the playback spectrum. So you can remove it, okay, and you can move it to different screens. You can dock it somewhere, like I can dock it here to the side, and then get the map here. So now I'm looking at the location of the car. This is playback again. This is here the playback track. So you can see the cars on the move and what is happening to the spectrum during that drive test. You can control the speed by clicking up and down, and you can pause and stop the playback. Now, I've got something a bit more interesting here, is the possibility to monitor real-time monitoring. So you can this is the device I'm going to use for the measurements. I can connect to the device, and you can see here it's connected. There's no error, and now I can do sweeping, start sweeping. So here I'm doing monitoring. I'm doing two jobs at the same time. I'm monitoring specific predefined channels. So let me expand this a bit. So here I am monitoring a set of frequencies. So you can configure this in an Excel spreadsheet. So I want to monitor specific channels, and then the tool automatically will start capturing measurements and then graphing these measurements. This is they don't have to be sequential. So it could be any frequencies in the FM band, in the AM band, in the VHF, UHF band. So the idea is to really keep an eye on specific frequencies, and maybe because you want to see if they are in use, if they come online or something like that. Maybe you are in a stadium, and then you are monitoring the spectrum for special events, and you want to see if anybody is using the spectrum for a specific channel, and then you can verify if it is them or someone else. Okay, so this is really useful because you can keep an eye on specific frequencies. Now at the same time, the tool would be, you can put this on a different screen if you have multiple screens, by the way. So let me dock it somewhere. So I'm gonna dock it here, and at the same time here, I'm looking at the sweep. This is a full sweep. So that sweep is doing FM probably. It's doing this start frequency, stop frequency, and RBW, and so on. So this is useful if you want to understand the spectrum as a whole instead of looking for individual channels. So yes, so this is something you can monitor in real time and then understand the spectrum usage, make decisions, raise alarms. Like, we could color a specific channel, a specific color uh, if something is detected. Okay, but the idea here is to give us insight into the spectrum, not just from a database perspective, but also from a real monitoring perspective. So that's it for now. And if you have any inquiries, please do reach out, and I'm more than happy to assist you. Thank you for your time.